Good morning, friends. Next, second unit, that is output primitives. So these are the content, that is points and lines, line drawing algorithm, DDE, diagonal line drawing algorithm, midpoint circle algorithm, midpoint ellipse algorithm, filled area primitives. Okay. Now first we'll see what is the point and what is the line. So point is the fundamental element of picture representation. It is a position in the plan defined as either pair or triplets of number of depending upon the dimensions. Okay, so 2 points represent line or edge, and three or more points as a polygon. Okay, so curved lines are represented by the short straight lines. Okay, so whenever we draw the images, we are into the points and lines. Okay, so in that way, point is the fundamental element of the picture representation. In that way, we can say that it is a main element of the picture representation. Okay, and also we can define the point. There is a position of the plane. We can define either pair or triples of the numbers depending upon the dimensions. Okay, and curved lines are represented by the short straight lines. See, whenever drawing a line drawing algorithm, there is a slope intersect value, that is y equal to mx plus b. So in that way, the main intercept equation is y equal to mx plus b. Then now we can find the m value, that is m equal to y2 minus y1 by x2 minus x1. Then intercept b equal to y1 minus m into x1. Then calculate of the interval calculations, that is delta y equal to m into delta x, then delta x equal to delta y by m. So this is the graph based upon the intercept equation. There is an intersection y equal to mx plus b. Based on that, we can create m value m equal to y2 minus y1 by x2 minus x1. Then intercept b equal to y1 minus mx1. Then interval calculation delta y equal to m into delta x, and delta x equal to delta y by m. Next, what is the line drawing algorithm? See, the process of turning on the pixels for a line segment, that is, the process of turning on the pixels for a line segment is called vector generation or line algorithm, line generation. And the algorithms for them are known as vector generation algorithms or line drawing algorithms. Okay. Before discussing specific line drawing algorithm, it is useful to note the general requirements for such algorithms. So, these requirements specify the desired characteristics of the line. That is, the line should appear as a straight line and it should start and end accurately. The line should be displayed with constant brightness along its length independent of its length and orientation. So, okay, the line should be drawn rapidly. So these are the requirements for can design can. First one is a line to be straight. There is a starting and ending is compiled accurately. Then it will display the constant brightness along the lengths independent of its length and orientation. Based upon the length and orientation, we can display the line. And next one is the line should be drawn in the rapidly. Rapidly we can draw the particular line. See here. See the different lines drawn here. See, this is the vertical and horizontal lines, and it is a 45-degree line. So likewise, we have to draw the line. Okay. See, line with other orientations. This is the one of the orientation. This is the one of the orientation. This is the one of the orientation. See, mainly we are used to the different type of algorithms. There is a DDA, next Bressenman's, likewise we can DD algorithm. What is a DDA algorithm? That is a digital differential analyzer. DDA stands for digital differential analyzer. Sample the line at unit intervals is one coordinate. So determine the corresponding integer values nearest to the line path in another coordinate. So based upon that, we can draw the line. So we can define the first we can define the different for the coordinate values. Based on that coordinate values, we can draw the lines. Okay. So for example, you have taken some sample units. Based upon sample units using of the DDA, you can define the different of the points on the starting ending. You can draw the lines. See, in the DD algorithm, there is a left to right. We are using the slope value m equal to yk plus 1 minus yk by xk plus 1 minus xk is equal to delta y by delta x, and also we can do y2 minus y1 by x2 minus x1. In that way, we can assign yk plus 1. If we have k equal to 1, that is y2 minus y1, that is by x2 minus x1, that is equal to delta y by delta x. From m is less than 1, that is delta y less than delta x, sample line at unit interval in x coordinate is y2 equal to m yk plus m, and delta x equal to xk plus 1 minus xk equal to 1. For m greater than 1, that is delta y greater than delta x, sample line at unit interval in y coordinate xk plus 1 equal to xk plus 1 by m, delta y equal to yk plus 1 minus yk equal to 1, and slope equal to m equal to yk plus 1 minus yk delta by delta x. From m less than 1, delta y less than delta x, sample line at interval is x coordinates yk plus 1 equal to yk minus 1, and delta x equal to xk plus 1 minus x1 equal to minus 1. For n is greater than 1, delta y greater than delta x, a sample line at unit interval in y coordinate, the xk plus 1 equal to xk minus 1 by m, and delta y equal to yk plus 1 minus yk equal to minus 1. So now we can implement the DD algorithm using of these steps. Okay, the first one, input the two line endpoints and store the left endpoint in x naught comma y naught. Plot the first point is x naught y naught. Now calculate the constant, that is delta x comma delta y. If delta x greater than delta y, that is delta x, otherwise delta y. Calculate x increment, that is delta x by steps, and y increment delta y by steps. At each xk along the line starting at k equal to 0, plot the next pixel at xk plus x increment, yk plus y increment. So repeat step 6 number of times. Okay. See, these are the steps from to implement the DD algorithm. That is, first of all, we have to find the in starting points. There is a x naught y naught. Based upon that, we can calculate delta x delta y. If delta x greater than delta y, there is a step delta x delta y. Calculate x increment, there is x and x by 1 plus equal to delta x by steps, and y increment equal to delta y by steps. At each xk along the line starting at k equal to 0, plot the next pixel at xk plus x increment comma yk plus y increment. Based upon that, we can draw the line straight lines from the using of DDA algorithms. Okay. See, this is a pseudocode void line DDA of int xa comma int ya comma int xb comma yb int dx equal to xb minus xa dy equal to yb minus ya steps comma k float x increment comma y increment comma x equal to xa y equal to ya. Condition, absolute condition we are applied here. If abs of dx greater than abs of dy, then steps equal to abs of dx as steps equal to abs of dy, then x increment equal to dx by float of steps and dy by float of steps. Set pixel round of x comma round of y for k equal to 0, k less than steps, k plus plus, and x plus equal to x increment and y plus equal to y increment. Set pixel of round of x comma round of y. So based upon pseudocode, we can implement the program of the particular line DDA algorithms. Okay. See, based on these steps, we can implement the pseudocode. Okay. Now we take an example of DDA algorithm. See, describe a line with endpoints 10, 15 and 15, 30. See, for example, can take the slope value. What is the equation of slope value? M equal to y2 minus y1 by x2 minus x1, that equal to 30 minus 15 by 15 minus 10, that equal to 15 by 3, that equal to 3. See, 3 is greater than 1, so that is modulus n greater than 1. So we sample at y interval. The formula is given by xk plus 1 equal to xk plus 1 by n. See, that is 10 comma 15, then x equal to 10, y equal to 16, then x equal to 11, y equal to 17, then x equal to 11, y equal to 18. Okay, so likewise we have to draw the line starting this. Use the straight line you can draw here. So for example, you have to take rastering the lines 0, comma 0, 2, 6, comma 6, and also use 0, comma 0, 2, 4, comma 6. We can implement it. See, the results are plotted like that. This is the result of the particular. Before example, this is the line drawing line. We can draw the plotted type. There is a circle step you can assign on here. Next, what is the advantages of DD algorithm? So it is the simplest algorithm. It does not require a special skills for the implementation. Simply we can implement x value greater than, we can increase the value. Okay. It is faster method for tracking the pixel position than the direct use of equations. See, y equal to mx plus b, it eliminates the multiplication in the equation by making use of raster characteristics so that appropriate increments are applied in the x or y direction to find pixel positions along the line path. Okay, so what is the disadvantages? Floating point arithmetic in DD algorithm is still time consuming. The algorithm is orientation dependent, so the endpoint accuracy is pure, so we cannot end of the point is not accuracy. Okay, this is the main disadvantage of the particular algorithm. And in that algorithm, we are define the floating points. It is not perfectly. The time is very consuming based upon the floating points. In that way, we are go from the Pristinam's line drawing algorithm. So use only increment integer calculation. Here we are using the which pixels to draw. That is the 11 comma 11 or 11 comma 12 or 51 comma 50 or 51 comma 49. See. For n less than 1, start from left endpoint x0, y0, step to each successive column x samples and plot the pixels whose scan lines y values is closest to the line path. After xk, yk, the choice could be xk plus 1, yk or xk plus 1, yk plus 1. See, y equal to equation m of xk plus 1 into plus b, then d1 equal to y minus yk, that equal to m of xk plus 1 plus b minus yk, and d2 equal to yk plus 1 minus y, yk plus 1 minus m into xk plus 1 minus b, because of y equal to m of xk plus 1 plus b. But here minus go, so minus of m of xk plus 1 minus b. So difference between the t stuff, that is d1 minus dt equal to 2 in 2m into xk plus 1 minus 2yk plus 2b minus 1. So defining the decision parameter, that is pk equal to delta x of d1 minus d2, that is 2 delta y into xk minus 2 delta x into yk plus c, that is the constant value, that is which are the independent of the pixel positions. Sign of pk is same as that of d1 minus d2 for delta x greater than 0, that is pk plus 1 equal to 2 delta y into xk plus 1 minus 2 delta x into yk plus 1 plus c. Then pk plus 1 minus pk equal to 2 delta y of xk plus 1 minus xk minus 2 delta x of yk plus 1 minus yk. Then pk plus 1 equal to pk plus 2 delta y minus 2 delta x of yk plus 1 minus yk. So because of xk plus 1 equal to xk plus 1, yk plus 1 minus yk equal to 0, that is pk less than 0, yk plus 1 minus y 1 if pk greater than 0, then we can calculate the recursive function, that is p naught equal to 2 delta y minus delta x, that is b equal to y naught minus mx naught, then submit m equal to delta y by delta x, then we will get the p naught equal to 2 delta y minus delta x. Okay, see what's the algorithm? See, input the two line endpoints and store the left endpoint in x naught comma y naught. Plot first point x naught comma y naught. Calculate constants delta x, delta y, 2 delta y and 2 delta y minus 2 delta x, and obtain p naught equal to 2 delta y minus delta x. At each xk along the line starting at k equal to 0, perform the following test. If pk less than 0, the next point plot is xk plus 1 comma yk, and pk plus 1 equal to pk plus 2 delta y. Otherwise, the next point to plot is xk plus 1 comma yk plus 1, and pk plus 1 equal to pk plus 2 delta y minus 2 delta x. Then repeat step 4 delta x times. So based upon these algorithm, we can find the strike time from the using of the basement and triangle algorithm. See, only calculations for constant delta x, delta y, and 2 delta y and 2 delta x once, and the integer addition and the subtraction these steps. For example, we take the values endpoints 20 comma 10 and 30 comma 18. So n equal to x2 minus x1, sorry, y2 minus y1 by x2 minus x1 can 0.8. Now we calculate delta x and delta y, that is x2 minus x1, y2 minus y1. Next we can calculate the p0, that is p0 equal to 2 delta y minus delta x, then we can get the 6. Now multiply 2 delta y equal to 16, then 2 delta y minus 2 delta x equal to minus 4. Now start of x comma y naught 20 comma 10. Now the pk value is 0 comma 6, 1 comma 2, 2 comma minus 2, 3, 14, 4, 10. That is k equal to 5, 6, 7, 8, 9. Then pk equal to 6, 2, minus 2, 14, 10. Then xk plus 1 comma yk plus 1 equal to 26 comma 15, 27 comma 16, 28 comma 16, 29 comma 17, 30 comma 18. So like that we have to calculate the value, that is k value, pk value, xk plus 1 comma yk plus 1, k, pk, xk plus 1 comma yk plus 1. Use Bernoulli's algorithm to transfer in the line, that is 5 comma 5 to 13 comma 9. So this is the result of the before example. So likewise you have to draw the line 1, 2, 3, 4, 5. See 1, 2, 3, 4, 5 points. Based upon that, we can draw the lines. We can draw a straight line. This is the straight line. This is a straight line. Okay. Based on these values, we can implement the lines. Next, using another example, that is we have take 15, 18 and 10 comma 15 using the Senate and algorithm. You can check in your houses. Okay. See here. This one. So 15, 18, 10, 15. The values are these xk plus 1 comma yk plus 1 of these values, that is 11, 16, 12, 16, 13, 17, 14, 17, 15, 18. See. Okay. Now like when using of these xk plus 1 yk plus 1, you can draw a straight line like these are lines. Okay. Okay. So next take the endpoints 15, 15 and 10, 18. So these are xk plus 1 yk plus 1. These are the values of xk plus 1 yk plus 1, 11, 17, 12, 17, 13, 16, 14, 16 and 15, 15. That is the diagram is like that. Okay. if m less than greater than 1. So input the two line endpoints and store the left endpoint x0, comma y0. Plot the first point x0, y0. Calculate constants delta x, delta y, 2 delta x and 2 delta x1 to delta y. Obtain p not equal to 2 delta x minus delta y. If reach xk along the line starting at k equal to 0, perform the following test. If pk less than 0, the next point plot is xk comma yk plus 1 and pk plus 1 equal to pk plus 2 delta x. Otherwise, the next point to plot is xk plus 1 comma yk plus 1 and pk plus 1 equal to pk plus 2 delta x minus 2 delta y and repeat step 4 delta x times. So based upon this step 4, we can implement the number of times. Okay, for example. So this example you can check into the house. Okay, so using line triangle algorithm, we are using the two techniques. The first one is DDA, that is a different digital differential analyzer, and next one is a Bessel's line triangle algorithm. So why you are using Bessel's line triangle algorithm? In a DDA, we cannot find the floating points. Floating points. Whenever take the floating points, it maybe take the time. In that way, we are go from the Personal plan algorithm, it is easy to find out. It is easy to form out the floating points values also. Okay, that way, in compared to the DDA, the business is the best one and the best one. Okay, next, go for the circle in genetic algorithm. So the basic foundation of the circle equation is x minus xc squared plus y minus yc whole square equal to r squared. So pointing along circumferences could be calculated by stepping along x-axis, that is y equal to yc plus r minus root r squared minus xc minus x whole square. So in the above method, we can use the computational complexity, that is the spacing, there is a non-uniform spacing of plotted pixels. There is no use spacing plotted points. Okay, so the computation is very complex. It is a spacing of that. There is a non-uniform spacing of plotted pixels. Okay, so non-uniform spacing of the plotted pixels. Next, spacing of the problems in previous is interchange the role of x and y whenever the absolute value of the slope of the circle tangent greater than 1, then use polar coordinates, that is x equal to xc plus r cos theta, y equal to yc plus r sin theta. Equally spaced points are plotted along the circumferences with fixed angular step size. Step size chosen for theta depends on the application and display the devices. Then the competition problem will use symmetric of circle, that is calculate for one octet and use symmetry for the others. So we are okay. So this is the two ways. There is a interchange the rule of x and y whenever the absolute value of the slope of circular tangent greater than 1. Use polar coordinate x equal to xc plus r cos theta, y equal to yc plus r sin theta. Equally spaced points are plotted along the circumferences with the fixed triangular step size. So step size chosen for theta depends on the application and display the particular devices. And we can find the computation problem is the symmetry circle, that is the calculate for one octet and use symmetry for the others. Okay, so likewise we have to calculate the circle algorithm, and using these things we can draw the circle algorithm. Okay.